Now, the clip that we're about to go into is actually about, I guess, Locke's argument for the very first premise of the Kalam, right? The causal principle. And I know that you have an argument against the causal principle just being accepted as like, something that's true. And so I'm just kind of curious if you can kind of give us an overview before we get into Locke's. I guess Locke considers this to be something that you haven't actually answered yet. I know a lot of people probably haven't read your argument. I was just wondering if you could give kind of an overview of your case against the causal principle.
Yeah. Does the clip you're going to show, do you feel that it gives you a good idea of where he's coming from, what his argument is? So
I think so.
Yeah. I don't want to brief it. I don't want to like put words in his mouth. If he's going to represent it, then we can let him represent it when we get to it. But as far as where my take was, now I actually have multiple arguments because I actually follow a disjunctive argument, which is it's either A, B, or C. If A, then this. If B, then this. If C, then this. But amongst those arguments, one of them is the one that I know that really like gets his goat, and he gets really annoyed by it, and that he misrepresents it a lot. But that's the nothing state argument that we'll get to. In general, the actual argument I made, and which is the primary argument I made in my article that launched the debate, right? So I did this article on my blog. You can find the links, I assume, are below. My point was that his first premise, as worded, is self-contradictory. And he even admitted this in the debate. He didn't admit the contradictory part, but he admitted that he does not believe that the first premise is a logically necessary truth. Okay, so if it is not logically necessary the case, and that is what you have to prove, right? If you want premise one to stand, you have to prove that it is logically necessarily the case that everything that begins to exist had a cause. You have to prove that that's always the case. Now, if they could do that, then premise one would be solid and we wouldn't need to continue, right? Like say, okay, I agree with the first premise, you proved it. But no one's proved that, right? There's no evidence that it's logically necessarily the case. Now, if it's not, that means it's contingent. If it's not necessary, it's contingent. If it's contingent, then that means there are logically possible conditions in which it is not true. So the premise is false, right? So like you're trying to say like everything that begins to exist has a cause, except for the logically possible things that don't have a cause, right? Like that's not a valid premise. And there's no way around this, right? Like, so you say it's a contingent, you got to treat it like a law of physics or a principle or whatever. Well, what about if it's contingent? What about before it was true? You can't, like, what caused the principle to be true, right? So you can't say that the principle held before the principle existed. So you can't say it is logically necessarily the case that something caused this causal principle. No, before the principle existed, then it was not true by definition that everything that begins to exist has a cause. Yet this principle that everything begins to exist has a cause begins to exist. But it cannot have had a cause, right? Or it didn't have to have a cause, let's put it that way, because the principle can't precede itself, right? It's a logical contradiction. There's no way around this. You just can't get the principle. The only way to get the principle to be valid at all or usable for the premise is to actually prove that it has to be true in all possible conditions. Now then, that's my actual argument, and that's one that Locke ignores completely and never addresses in any other stuff. He just skips right past it. What I then say, I'll say like, well, okay, given that, let's put our thinking caps on and let's imagine like, what is a condition? I wonder, like, in what condition do you think this principle wouldn't apply? Like, when would it not exist? What would that condition look like? Well, I mean, one possible condition is when there's nothing, right? Like, if there's nothing, there are no laws or principles. So therefore, this principle cannot have existed, right? If there's nothing, then this principle doesn't apply by definition. So that's a good candidate for when this principle wasn't true. And therefore, you have to explain how did this principle arise from that state? And then you have to give like an explanation for that. They don't even try. I think cosmological scientists have advanced some really interesting theories that come up with this. I often brought up the Lincoln-Walcher model, which is a really good paper on creation ex nihilo, which is a conceptual paper that dovetails pretty closely with my argument. And they did this independently of me. So we two groups thinking of the same thing independently. It's a good sign. So I felt somewhat vindicated when I found that paper, and it's a peer-reviewed cosmological paper. And so the Lincoln-Walcher model is that if you subtract everything, and this is what I did too, it's almost word for word in some cases. If you subtract everything, like what would nothing be, right? Like, so the argument is that Krauss, for example, the universe from nothing, is the book. And then people criticize him for saying, well, but really you start with something. You start with a set of quantum laws and this sort of bubble of false vacuum, and you start from there, and yeah, there's a lot of stuff not there, but it's not completely nothing. It's still something. And so they say, well, where did those laws come from? Where did that bubble come from, et cetera, et cetera? Okay, valid question. So that's where that comes from. Now, What Lincoln and Walcher did is say, okay, let's subtract everything. Let's get rid of the bubble. Let's subtract space down to zero, time down to zero. Every law of physics, we're going to dial it to zero. Every particle, we're dialing to zero. So everything's zero, and then they analyze and train that, well, if everything's zero, then there's nothing to constrain what will happen, right? Because it's unstable, because it's just going to randomly collapse through spontaneous symmetry breaking into something else. And then it's just a question of what would be the inevitable outcome. And that's their model, and that's kind of close to what my argument was, is like, if you subtract everything, what Locke will do is, he doesn't like this, right? He really doesn't like it. What he will do is he will misrepresent what my theory is. And this is the same thing that Alvaro did and various others. I've caught them. Kuhn's did it, and I've written about this multiple times. They do it every time. Is that when I say absolutely nothing, I always qualify, and I say, by which I mean the most nothing that could logically ever have existed. So we're not talking about a state of nothing that's logically contradictory, because we know logically contradictory states can never have existed. So what I say is, like, when you have nothing except what logically necessarily follows from that. So some things do exist, and some things do operate. Some rules do apply. All the logically necessary rules apply, right? So it's not an absolute nothing in the sense that there's nothing. It's just nothing measurable. There's no space, there's no time, or at least space and time are at zero. So you could say that there's a 0 point of space and time. So you can say, is that something? Does that count as something? And that's what Locke will do, is like, he'll skip and say, well, that still counts as something. Therefore, nothing has to be even less than zero, which, not a negative number, but I mean, like, even more nothing than nothing, which is contradictory. But anyway, my argument was that that's self-contradictory, and so that nothing state can never have existed. So if nothing did exist, or let's maybe put it another way, if they insist that even a 0 point it's a place, but it has zero length, zero time, it has no laws of physics, it has no matter, no energy. If they're going to say that that's something, then they're basically saying, and then they're going to say, like, if there's nothing, then nothing will happen. Well, then they're basically saying that nothing is logically impossible. And I agree with them. If they mean that nothing has to be something less than what I'm describing, that state of nothing can never have existed. So we're not worried about that. But if we're saying, like, something had to have always existed, or something started everything, and we say, well, we can explain everything with a nothing particle, like something has zero length, zero time, zero rules, zero matter, zero energy. If we can start from that, and everything that we observe results, like we can show that necessarily it ends up happening to be the case, then we don't need God, right? Like, we've sorted the God problem, right? Now, if you want to call that something, well, it's just semantics. Like, we don't care, right? Like, yeah, sure, call it something. I don't care, right? Like, if you want to call that something, I'm okay with that. But then acknowledge the point that, like, we can explain all observations better even by assuming that that's how things started than with a God. And this is the argument that they will skip. They'll play semantics, word games about what nothing means, etc. And they'll just say, well, you still have to explain how the nothing's point it came to exist. You mean how I have to explain how once we subtract everything and have nothing, you want me to explain why there's nothing? It's like, that doesn't follow. Nothing has to cause a 0 point of space-time to exist. When there's no space and no time, there is a 0 point of space-time. It is a logically necessary truth, right? Like, that is what it means to have zero space and zero time. So there is no further state of nothing. You can't get any more nothing than that. Anyway, so the point that we can start with that and explain all observations is a good cosmological theory, right? And it refutes the first premise. Now, there's another semantic game they can play, which is the idea that, well, okay, we're talking about, if you define that point, you can physically work out that it will be unstable and it will spontaneously break into a multiverse. So you can say, well, that's a cause, right? So technically, sure, if you want to call just random spontaneous appearance of stuff that necessarily results from a given state, if you want to call that a cause, that's semantics again, right? So you say, well, everything that begins to exist has a cause. Well, if you're allowing even random, unprincipled, random spontaneous generation you're calling even that a cause, well, again, we don't need God, right? Like, you're defining your premise so far out that God is no longer needed, right? Now we can do it with just a 0 point. 0 point containing nothing. We can explain everything from that. So calling it something and calling that a cause doesn't do anything as far as the argument. It's all semantics. It's semantic shell moving, right? So this is the kind of game playing that Locke will do, especially with a nothing argument. And again, remember, this is just one possibility. I also talk about past eternal models. I also talk about actual more substantive something states. That's another point. Like, you can have something that isn't as nothing as I'm talking about, let's say the first cause is just Krauss's quantum principle. There's just a quantum bubble of space-time? Maybe. I mean, that's just as likely as there being a God, right? Without any other further evidence, right? Like if you're just going to make shit up and say there just was this thing there, no explanation, and you're going to say like, it had to be there for logically necessary reasons. We can say, well, we could say that about the quantum bubble, Krauss's quantum bubble. It just it has to be there. I mean, I don't have a proof of that. You don't have a proof of yours. So we're awash, right? So that's the other side of the argument. Those are the kinds of arguments that go in different directions. But when I do bring up the nothing argument, that's where that Locke just freaks out and can't handle it.
Yeah, I've noticed. as we'll see, he totally just, I guess he just ignores your actual argument and instead makes, he makes up reasons, it seems to me. But I'm gonna let him speak for himself.
And then I can evaluate based on what I've read, because I've read tons of his stuff. So it's worth pointing out the Kalam cosmological argument has never passed peer review in cosmological science, unlike tons of cosmological theories that are even weirder. They can pass peer review, but even the Kalam can't even do it. So that tells you like scientists are not impressed with the Kalam cosmological argument.
Well, and I was thinking while you were kind of giving your overview, a practical example of how the first premise of the Kalam fails is something mentioned in one of the Skydive Phil videos, and that's radioactive decay. The actual atom that ends up degrading into the daughter element, that is a completely random process with no discernible cause. And so
let me play devil's advocate for Andrew Locke here.
Okay.
I know what he would say, and I would agree with him on this. This gets back to the Krauss argument. Is that's true? I mean, it's true so far as we know. Let's put it that way. Like we don't know. There could be hidden causes that we can't see. But so far as we know right now, there doesn't appear to be a cause. It appears to be randomized. And it could be fundamentally random. It's possible. But Locke would point out that, well, notice how it's constrained only to specific atoms, only in specific ways. It follows specific rules. And there's a whole quantum theory of virtual particles and stuff that it's a part of. So what he says is like, well, there's a space-time that has properties governed by quantum laws. Those are still ontologically causing the randomness, right? Like there's still a state of affairs that exists that is producing that randomness and not other random things. So this is another thing that Locke goes on about is like, why aren't rabbits just popping out of everywhere, right? Like this is, why aren't there just rabbits jumping out of my computer and, popping out of my hat and my pants all the time? Like, why aren't there random things just happening all the time? Okay, we can explain this. This is the same thing that I just said. It's like, yeah, we live in a principled space-time, rules governed, physical substrate that follows certain physical laws and has certain physical properties and certain physical contents. And those laws and properties constrain what can and cannot happen. Maybe we'll get into this more later, but where we are now has that. And so you do have to explain why. Where does that substrate come from? Why does quantum decay happen? Why does it work the way it does and not other ways? Why is it only that and not rabbits, right? It's like there's a lot of questions you have to answer. And that's what they're trying to get at cosmologically is like, what caused that state of affairs to exist? So it isn't. So the question is that they still see that as a cause, even though it's random. There still is a cause. You have to have certain atomic masses. You have to have certain neutrons and protons, certain number of them in a certain particular way that causes the spontaneous decay, right? So even though it's random, it still has a cause, and that cause can still itself has to be explained. Why does that? Where did that cause come from? Presumably, it began, and so what preceded it, etc. And so that's a valid argument. I agree with Andrew Locke on this. I agree with the Kalam proponents on this point. And so that's why I think if you want to get behind things, there does have to be a first thing. Maybe it is the quantum bubble. Maybe that's just a brute fact. It just exists. It's possible it's the first thing and it doesn't have a cause. Or maybe it's less than that. Maybe it's like Lincoln-Walcher. And what I've argued is that we go all the way down to zero and we have an actual cosmological spontaneous symmetry breaking argument for why the multiverse would arise, right? So why laws of physics, including the causal principle, would emerge from this acausal first state. So there's a variety of different ways to solve the problem, but they are correct that the problem does need to be solved. And what their argument is that we can't solve it, therefore a God, right? Like that's the common God of the gaps argument. It's like, because we haven't answered this yet, God is the only explanation. And then they have a lot of other bullshit and rigmarole to try and get God to be the only answer. But the fact is that God isn't the only answer. We have tons and tons of answers in the cosmological literature that don't involve a God. And they might not like those that might annoy them. I can't help with that. But the proposals are there. So we have ideas, and so there's possibilities. So because there's possibilities, we haven't proved God either. So you can't argue to God from this way, right? Like maybe if you come up with a cosmological theory that makes empirical predictions that are distinctive to your God hypothesis and not made by any other non-God hypothesis, you publish it, you make those observations, and you confirm your God theory. Well, that's how a cosmological science theory would work. That's what you have to do. That's what other cosmological scientists are doing, but they're not doing that. They're skipping all the science and pretending that they can jump straight to God as a theory, even though that's the least plausible theory of any that there is. But the question is still worth asking and is still worth exploring philosophically. What are the possibilities, etc. So that quantum acausal argument, I do reject it. That is not a valid argument against the Kalam. And Andrew Loke would say the same thing that I just said about that.
Okay. Yeah. I mean, that was one thing that I remember from, because I watched both of those documentaries that you sent me today. And that was one thing that they brought up as like not needing a cause, or at least no discernible cause.
In that video, their point is that if you have this instance, then you could maybe start with a first principle, like a first thing, and they disagree on what that first thing could be. Well, they all agree it could be a variety of things, but they all have their own pet projects, their own pet theories. And you can say, well, it could just be a spontaneous decay of a particular field state, an ultra simple beginning field state. Yeah, that could be. Now, that does require you to posit that there was just a certain law of physics that just was there and has no cause, which that's as likely as there being a God, right? Apart from until you start looking at evidence, then the God theory really tanks as a plausible theory. But if you didn't have any other evidence, you just had a list of possibilities, God is on the list, but so are a bunch of other things. And what they're talking about is one of them, like the spontaneous decay argument. And there's a lot of those in the cosmological literature, examples of spontaneous wave collapse causing the universe from virtually nothing. So that's an actual model. Multiple versions of the model are out there. I linked to some of them, some of the papers related to that in some of the articles that are below.